Today we're going to be presenting on our Spotify Hit Predictor project. I'm Jonathan.
And I'm Anna. We wanted to see if it was possible to algorithmically determine whether a song would be a hit or not. Art is highly subjective, so it might be really useful for music producers and labels and even artists themselves to know what features of a song can make it more popular.
So yeah, in regards to the data set, we retrieved over 40,000 tracks directly from Kaggle. Each of the tracks is labeled as a hit or a flop. That's our target label, as well as a number of features, which you can see on the right. The songs are separated by decade of release, downloadable in a CSV by each decade. And the features themselves are objectively generated from the audio of each song. And by that, we mean they're not labeled by any particular user or any particular producer. They're labeled exclusively using Spotify's analysis of algorithms. In terms of our target is purely binary. A variable can either be 0 or 1. 1 implies that this song was featured in Billboard's Hot 100 tracks of that decade at least once. And that means that song is a hit. If that target is a 0, that implies the track is a flop.
For pre-processing, we used a correlation. We used Pearson correlation and a correlation matrix to determine which features in the data set are highly correlated and should be removed. You can see to the right the Pearson correlation. And then as well as that, we use scikit's standard scaler to standardize the data.
As you can see here, we decided on a few models: rich classifier, random forest, logistic regression, and decision trees. We also used k-fold cross-validation to validate whether our models were robust and performed well. And with that, we used sklearn's grid search CV to tune the hyperparameters.
In terms of existing work that people have done on the similar type of topic, on the left, we have predicting Afrobeat hit songs using Spotify data. And this one, they use similar Spotify data and similar models that we are using. They also use linear regression, decision trees. They use neural networks, which we're not using. But they're able to get a pretty good accuracy with a lot of these models. And then for this one on the right, is from an article where they use Spotify data to predict what songs will be hits. And below is the results from that, from their models. And they also got pretty good results for random forest. And these two existing works influenced our decisions for what kind of models we were going to use, because they were able to attain such pretty good accuracy with their model selection.
And finally, our preliminary results. So on the left here, you can see a chart of some of the models we ended up testing, as well as their test accuracy purely. In the future, this will also be supplemented by validation accuracy using cross-validation. Using grid search CV, we were able to tune the hyperparameters. And you can see those hyperparameters listed here for ridge classifier and logistic regression. Random forest, we did run into a little bit of a snafu. It still needs further optimization. And this is due to something we discussed in class, which is that random forest tends to take a very long time to optimize using cross-validation. So in the future, we're going to continue to optimize our random forest model. And we will have to figure out how to do out of bounds error and use grid search CV with out of bounds error or some other method, either developed by ourselves or by sklearn to find the hyperparameters.
And that is it for our presentation. Thank you very much for listening.